Bismillahirrahmanirrahim. Dear students, welcome to the class of electric circuit analysis. In this video, we are going to solve quiz number 2. We had two questions in quiz number 2. In this video, we are going to solve question number 1. Question number 1 says that determine the voltages V1 and V2 and also find the value of current I. The data we have is R1, which is 6 ohm, R2 5 ohm, R3 7 ohm, R4 6 ohm, E1 applied source is 6 volt and E2 is 18 volt. Using this data, we have to find the value of V1, V2 and I, the current. So from the previous circuit, we can see that R2 is parallel to R2 is in series with R3. So we can write R prime is equal to R prime is equal to R2 plus R3. By substituting the values of R2 and R3, we get R prime is equal to 12 ohms. Now we have to find the value of V2. What is the value of V2? We can see that V2 is parallel to E1, so we can say that V2 is equal to E1 because they both are in parallel, but the polarities of E1 applied force is opposite, so we can say that the value of V2 is equal to minus E1. When we substitute the value of E1, we can see that it is equal to minus 6 volt. Minus sign indicates that the value of the polarities of E is opposite. So we can say that V2 is equal to minus E1 and V2 is equal to minus 6 volt, which is our required result. Okay, now we have to find the value of V1. V1 is the voltage across resistor R1. In order to find the value of V1, we apply KVL on that loop. KVL states that sum of all the voltages rise is always equal to sum of all the voltages drop in a closed loop. So when you see there in this loop, you will see that the voltage across E1 rises, the voltage across E2 rises, but the voltage across R1 drops. So the equation of the KVL can be written as V1 is equal to E2 plus E1. V1 is basically the voltage drop across the resistor R1. E2 and E1 are the voltages rise in that loop. Substituting the values of E2 and E1, where E2 is equal to 18 volts and E1 is equal to 6 volt, we get V1 is equal to 24 volt, which is a second required value which we have to find in this question. Now we have to find the value of I. In order to find the value of I, you must need the value of I3, you need the value of I2, and you need the value of I1. We see that we have the voltages across each resistor. We have voltage across R1, we have voltage across R4, we have voltage across R prime. This is the R prime. When you have the voltages, when you have the value of the resistors, you can find the value of I3, I2 and I1. When you have these three values, you can apply KCL at that point and you will find the value of I. First we have to find the values of I1, I2 and I3. First I1, we have the value of V1 here and R1 is a resistor, so we can find the value of I1 using Ohm's law. Substituting the value in this equation, we get I1 is equal to 24 is the value of V1, 6 is the value of the resistor R1, and you will get the value of first current I1 is equal to 4 amperes. Similarly, when you are finding the value of I2, you have to know the value of V4 and R4. R4 is basically the resistor and V4 is the voltage across that resistor. You can see that R4 is parallel to E1. It means the voltage across R4 is same as the value of E1. So substituting the values, we get I2 is equal to 6 by 6, which is equal to which is equal to 1 ampere. So we have the value of I1 and I2. Now we have to find the value of I3. From the circuit you will see that this is the value of, this is basically the resistor R prime. When you are finding the value of I3, you must need the value VR prime, which is also parallel to E1. So substituting the values, we get 6 by 12. 6 is basically the value of E1, which is parallel to R prime, and 12 is the value of R prime. So we get I3 is equal to 0.5 amperes. Now we have all the three values of the current, I1, I2 and I3. Now applying KCL at this point, you will see that the current entering the node is I, current leaving the node is I1, I2 and I3. So when we apply the KCL, what KCL says that sum of all the current entering the node is always equal to the current sum of all the current leaving the node. So when we apply KCL to this point, which we call K point, we get that equation I is equal to I1 plus I2 plus I3. We have all the values of I1, I2 and I3. Substituting the values into it, we get 4 ampere is the value of I1, 1 ampere is the value of I2 and 0.5 ampere is the value of I3. When we add all these three values, we get I is equal to 5.5 amperes, which is our required result. Now we see that we find the value of V1, we find the value of V2 and I. These are the required values which we have to find in that particular question. If you have any question related to this topic, you can drop a question in comment bar. Thank you very much.